and all that is good and great is steamhead up to now. Well, I'm in a caravan on the Isle of Wight, and we have a tradition in the UK where April, May, June and half of July are really hot months, not a cloud in the sky, beautiful weather. And then you go on your summer holiday or vacation as in America, and it starts raining, and then it just rains basically until you get home again. The reason we're in a caravan, in fact, at the moment for this holiday is that 4 years ago we came away with a tent, funnily enough, for a campsite. And we'd just suffered 3 months of boiling hot weather. As I put the key in the door to lock it, it started raining, and then it rained and had gale force winds for the first week, which drove me almost insane. Luckily, the campsite had a spare caravan, which we spent the second week in, which was brilliant. Walls, roof, ceiling, windows, comfortable beds, not being buffeted by wind all night. So I'm bored basically because I'm stuck in here. So what I thought I'd do is to get on with designing some of Victoria the automaton, and to try and make a video on a young person's smartphone. This is my phone, and as you can see, it's a little bit limited, but it's a telephone. It does everything I want. So back to Victoria the automaton. Now I want the prototype for Victoria to be to host a quiz, a multiple choice quiz. So I need a way of users, or clients as we shall call them, to input one answer, A, B, C or D. And I thought the best way to do that, rather than using buttons which are boring, is to use organ stops or something that looks like them, because they are just such a classic design and they're amazing. The history behind them, the way they work mechanically, are beautiful things. I need some way of knowing whether they're in and out, whether they've been pulled in or pushed out, or pulled in and pushed out or something, and also to move them as with real organ stops. So after each question has been entered and we move on to the next one, they all go in. And I was thinking, how can I do that? Well, here's an example. I could have a rack and pinion with a motor of some sort that would drive this in and out. And I thought, well, perhaps rather than that, because that means that each one is independent, perhaps I could link them together. So I thought, here's a suggestion. Each organ stop would have, or each stop would have, a pulley on it, and pulleys fixed to the back, linked by a piece of elastic that would go to a crank here, with an extra loose bit of elastic that would allow one stop to be pulled out at any one time. Now if you think about it, that means if I pull another stop out, this one pops back in, and if this rotates, the crank rotates on a motor of some sort, all of the stops end up being pulled back in. So that would work. But then I thought, well, not sure, because you could leave two of the stops halfway up, no way of knowing. And I thought about having two motors driving each stop with a rack up the centre. Two motors simply because the gears are quite small, because you can't gear it down too much. Then if you did, you try and pull the stop in and out manually, and it would be so geared the motor would spin round and the gears would wear out. So having two motors would mean that it was twice as powerful, and these little motors are really simple and cheap and everything. And then I thought, ooh, cunning plan here. Why not use opto-isolators connected across the motor? Now opto-isolators are used in medical equipment and anywhere that you want to isolate some sort of data signal from another part of the circuit. So in medical equipment, you don't really want to give the patient a huge electric shock because something's gone wrong, unless you want to give them a huge electric shock, that is. And you use an opto-isolator. They look like 8-pin DILs, dual inline integrated circuits, but inside one side the pins are connected to an LED, and the other side the pins are connected to a photo transistor. That means that you have a physical isolation between the input from data to the LED and the output from the photo transistor. Physical distance. It also means if I put them across the motor, as you will probably be aware, if you turn a motor fast, it creates electricity. So if I drive it, it will move the stop in and out. if a person pulls it in and out, it will then create a small amount of electricity that hopefully would be enough to run an LED and an opto isolator, and then that could be connected to inputs on the Arduino, so the Arduino would know if it was being pulled in and out. Therefore, if you pulled one out, it could pull, or the Arduino could drive all the others in and also make sure that this has been pushed out fully. So interesting. Also, on this page, just doing it in chronological order, as we say in the trade, starting to think about how an enclosure for Victoria, she needs to be enclosed in glass, because obviously in public places she could be damaged. And then I moved on swiftly from that to think about better ways of getting stops to work. Thinking about, well, springs each one and having some sort of latching mechanism. Then I remembered, when I was a small child, many moons ago, someone gave me a broken one of the very first electronic calculators. It was huge, the size of a very large suitcase, and it was covered in buttons, because each part of the number you put in had 1 to 10. I never understood how that works, but it was fascinating, and it showed you the answer, the result, if you like, on Nixie tubes. It was a beautiful thing, and it used dozens and dozens of little vacuum tubes inside to do all the calculations, but it didn't work. The numbers that were shown on the Nixie tubes had absolutely nothing to do with what buttons you'd pressed, hence the fact I ended up with it. But I remembered that these rows of 10 buttons, you couldn't press 2 at once. You could only press 1. If you pressed a different one to change the input, the first one would pop up. And I remembered it had something to do with thin strips of stamped out metal that would slide left and right, as did lots of control knobs in those days, because that was before the age of digital electronics and boring inputs. And I started thinking about it, and I'm so pleased I came up with the solution. If you imagine there's one stop and there's another stop, and they're being pulled that way by springs, that means that they will always be pulled in. You have a sheet of wood or something, plastic, with these Z shapes cut out, and in resting position, because there's a spring pulling it this way, there's a pin on top of each stop which sits there. Now if you pull one stop forward, it will then push this way until it reaches the end, and it will snap back really quickly, and it will hold the stop that you've pulled in the pulled out position. And secondly, it will also lock all the other stops so they can't be pulled out, which is great. Now the other good thing about this system is, if you then decide that you've pulled out the wrong stop, if you pull out a different stop, this new stop will then shove this bar, this piece of metal, one way and release all the other stops, so they all snap back. And also at the end, after each question, you want to pull all the stops back in, you could just have a motor, cam or crank or something to slowly pull this forward, and all the stops will go in. So I'm very happy. Currently it's a toss-up between this version and the electronic version. I'm not sure, I need to wait till I get home so I can then do some experiments. So next thing then, on to how to tell Victoria that you want to get her opinion on something or take part in a quiz. So you could have a rubber bulb, like on the back of one of the bike horn things. You squeeze that, she could start, or something like a one-armed bandit, but that looks too much like a one-armed bandit really. Or something like Florence had, where you lifted a lever up, it stuck at the top, and then when she'd finished working it would drop down. But